Hello, and welcome to Backer Breaks It Down. In this episode, we are going to take a look at quadratic functions with a focus on finding the zeros of a quadratic function by factoring and using the zero product property. Okay, so zeros of a quadratic function, those would be what we also know as the x-intercepts. And one way you can find zeros is by factoring. So let's check that out. So just to let you know, quadratic functions may have two, one, or no x-intercepts. The bottom of my slide here, I have that example of what one x-intercept would look like. The two x-intercepts is probably most common. And yeah, it's like totally possible for there to be no x-intercepts. Okay. So you can easily see the x-intercepts where a graph is crossing or touching the x-axis. The x-intercepts can also be found algebraically by solving an equation that is the function equals 0. So this is how you can find the x-intercepts for any functions. The y-intercept of any function can be found by evaluating f of 0 or simply by seeing where does it cross the y-axis on a graph. But let's talk about finding x-intercepts, okay? So like I said, they can be found algebraically by solving this equation f of x equals 0. So you can take a quadratic equation and you can write it in its factored form. So you'll get the factored form equals 0. And then the zero product property basically says to take each factor and set it equal to 0. So here they're like, well, x plus 3 equals 0, x minus 5 equals 0. And then you would simply solve those equations. So you'd get that one of your x-intercepts is -3, and then the other one is 5. Okay, so we have to write it in factored form and then simply use the zero product property to find the actual zeros. So there are two cases of factoring that you can encounter. This is the nice easy case when it's just 1x squared. That's nice and easy. And so in this scenario here, you simply want to find the factors of c, which is the constant term that add up to be the middle term. And so that's what I'm doing here in this little table is I'm finding the factors of -24 that add up to be 5. And so the two factors are 8 and -3. And so then I can simply write 8 and -3 as a product of two binomials. So one of my factors is x plus 8, the other one is x minus 3. And then from here, I can use my zero product property to find the zeros. So I'm taking the factor, setting it equal to 0, and solving. Factor, set it equal to 0, solve. So -8 and 3 are both zeros of this particular quadratic. Okay. So before I go to explaining the not so easy case, let's just take a look at example number 1 in your notes. All right, so for this quadratic function, I want to factor to find the zeros. I also want to find the y-intercept. So the y-intercept, that's really easy to do. You just want to evaluate the function when x is 0. And so if you think about it, if x is 0, what do you got? All you have is -12. So -12 would be your y-intercept. Nice, simple. It's also the constant term in this particular function form. So now let's do the factoring. This is that nice easy case where it's just 1x squared. So I simply need to think what multiplies to be -12 that adds to be -4. So this right here is the hardest part of factoring. If you ever get stuck, get out a calculator and just start dividing. But if I go 6 times 2, and then 6 is negative, this will give me -12, like it multiplies to be -12, and then it also adds to be -4. So I can write my factored form as like x and then -6, and then the x and the +2. And then when it comes to my zeros, I'm simply, and I can do this mentally, take each factor, set it equal to 0, and solve. So if I take x minus 6, and in my head, this is what I'm doing. I'm going x minus 6 equals 0, and I'm solving this. I get that x is equal to +6. Okay. If I do the same thing with x plus 2, and I create that equation of x plus 2 equals 0, and I solve it, I get that x is -2. So my zeros are 6 and -2. But this was like the nice easy factoring case. So let's talk about what if there is a number in front of the x squared? Well, honestly, the first thing you should do is look to see, is that number a common factor? Because, well, common factors could totally be the reason why you are seeing this a number times x squared. But if it's not a common factor and it's still there, then we do need to go through a little bit more of a process in order to write it in factored form. So step one is to multiply the first term and the last term. So if I go 3 times -7, I'm getting -21. Then we want to find the factors that give us -21 that add up to be the middle term. So your middle term is -4. So I found the factors. I got -7 and 3. From there, we are going to replace the middle term with these factors. So you'll notice that originally the middle term was -4x. It is now replaced with the -7x and the 3x. And then I'm factoring by grouping. So when you factor by grouping, you group the first two terms, you group the last two terms, and then you take the common factor out of each group. So, and then write down what's left over. So the common factor in the first group is x, and then what's left over is 3x minus 7. The common factor in the second group is +1, and then what's left over is 3x minus 7. And so this reveals your two factors. So notice like the 3x minus 7 was obvious to begin with, and then the x plus 1 gives you your other factor. And then from here, you're just using your zero product property where you're setting each factor equal to 0, and then you're solving for x. So the zeros of this one are 7/3 and -1. So let's take a look at a similar example in your notes. That would be example number 2. So the first thing I could very easily do before I get into the factoring is find the y-intercept. Remember, that's the value of the function when x is 0, so the y-intercept is simply 21. So now I'm ready to do my factoring. So remember, I'm going to look for common factors first. I don't see any. And then I'm going to multiply my first term and my last term. So 2 times 21 is 42. And then I need to find the factors that add up to be the middle term, which is 13. So it has to multiply to be 42 and add to be 13. 6 times 7 does indeed multiply to be 42 and add to be 13. So now I'm ready to replace my middle term with my two x factors. So I'm going to have 2x squared plus 6x plus 7x plus 21. And then I'm going to factor by grouping. So that means I'm going to group the first two terms. I'm going to group the last two terms, and I'm going to take the greatest common factor out of each group. So for this first group, that would be 2x. And then I write down what's left over, which is x plus 3. In that second group, the common factor is +7. And then what's left over is x plus 3. You see how I have x plus 3 in the parentheses for both? That's exactly what you should see, okay? Because that forms one of your factors. X plus 3 is one of our factors. And then the other factor comes from what we took out. So we took out this 2x and we took out this +7. That's where the second factor comes from. So my factored form, I've got the x plus 3, and I've got the 2x plus 7, and then I can use my zero product property to find the zeros. So x plus 3 indicates that -3 is a 0. And then the 2x plus 7, if I set that equal to 0 and solve, I get that x is -7/2. And that would be my other 0 of my quadratic function. Okay. So factoring is just one way that you can find the zeros of a quadratic function. Okay. So if your function can be factored, do so, factor it, and then use your zero product property to find your zeros. Just simply set each of those factors equal to 0 and solve for x. And that's how Backer breaks it down.